For more advanced students whose computational thinking skills are already well developed, there are interesting variations and ways to add complexity to our simple LED program. And this is where the benefits of using Scratch4Arduino will really be clear. The drag and drop aspect of Scratch allows the user to experiment and to quickly see problems with logic and strategy. For example, let's make the LED blink when the button is pressed. Let's simply add a digital off block right after the digital on inside our if statement. So when the condition is true and the button has been pressed, the LED will go on and off and on and off. It's useful to have a wait in between the on and the off so that the alternation between the two is not too quick to see. How about a variation on this program where the LED turns on when we press the button and stays on until the button is pressed again? Press the button once, the light comes on and stays on. Press it again, and the light turns off and stays off. This is called an alternating action switch. Let's try some obvious things to turn our original LED program into the more complex program, the alternating action switch. We want to keep the light on even after we release the push button. So maybe adding a forever block inside the if statement will lock the LED permanently in a state of being lit. Let's try that. No, unfortunately, it's not what we want. The LED stays permanently lit even after we press the button a second time. So let's try something else. There is a block called a wait until block. Perhaps we can have the LED turn on and wait until digital 2 is pressed one more time. The next time digital 2 is pressed, it will stop being on. Let's test and see if that works. Unfortunately, the result is unsatisfactory. The wait until block just seems to get ignored. I leave it up to your students to understand exactly why that is. And we have a circuit that behaves exactly like our original simple LED push button circuit. Those of you who have taught programming logic before will be able to appreciate how useful it is to have a physical button to press. And your students will thank you for the ability to write code with a mouse. It will make it easier to test their logic and to test their programs, especially the less experienced programmers. However, the programming interface won't do the thinking for them, and the program we are trying to write turns out to be quite challenging. In order to turn our push-button circuit into an alternating action switch, we need variables which we can create in the Variables tab in the Blocks palette. There is no way around it. The variable will keep track of the state of the button. In fact, we will need 3 variables, one for the current state of the button, another to hold the previous state of the button, and one that keeps track of whether the LED is on or off. This is what your final program might look like. The key conditional statement is the one expressed in the first if block. It tests to see if the button went from being unpressed to pressed. Unlike our previous programs, this program is not simply interested in the current state of the button. It also needs to detect if there was a change in the button's state. You see that when we press the button, the LED is latched. It stays on or off until we press the button again. This more complex program, the alternating action switch, would be a great project for students more advanced, ages 16 and up. for example, British A-level students. Adaptive maintenance is making amendments to an algorithm in response to specification changes. The added requirement that the LED stays on until the next button press is a great way to challenge students to alter their code to respond to this new requirement.